Hello friends, welcome back to your UPSC. So today in climatology we will be doing temperature. So let's get started. So today's topic will be temperature. But here the temperature, it signifies the atmospheric temperature. Okay, and as we all know that we all get energy from the sun. Okay, so the sun is the major source of energy. But for atmospheric temperature, sun is an indirect source of energy because most of the energy that the atmosphere receives is from long wave terrestrial radiations. Okay, this we have done in insolation chapter. And the heating and cooling of atmosphere is accompanied through direct solar radiation, through transfer of energy from the earth by the process of conduction, convection and radiation. So there are four processes. First is direct solar radiation. Next is transfer of energy from the earth via convection, conduction and radiation. Okay, and the least contribution will be of direct solar radiation. Now let's discuss the whole process of heating and cooling of atmosphere. So how the atmosphere get heated up or cooled down. So the process is like, first we receive solar energy. The earth's surface, it receives solar energy. This energy is converted into heat energy and it is stored temporarily. Okay, and after some time it is radiated back from the surface. Okay, and this radiation which is given back from the surface is known as ground radiation. Okay, but some part of this radiated energy, the energy which is radiated back from the surface, is stored by the atmosphere. How it is stored by the atmosphere? There are various greenhouse gases like carbon dioxide, water vapor, etc. They store this energy and they reflect it back to the earth's surface. Okay, so the radiated energy is stored, it does not escape, while some part of it is stored, and this stored energy is again reflected back to the earth's surface. So this radiation which is reflected back to the earth's surface is known as counter radiation. Okay, now there are various processes which we have to discuss in detail about heating and cooling of atmosphere. So the basic process of heating and cooling of atmosphere is by direct insolation. So the atmosphere gets heated up by direct insolation. So now here we have sun. Okay, so the energy which we get is from photosphere. Consider this as the photosphere of the sun. So energy is coming, it comes to the earth. Now 14% of this energy 14% of this energy is absorbed by the atmosphere. Okay, these are incoming shortwave radiation, and these incoming shortwave radiations, 14% are absorbed by the atmosphere. What are the absorbing elements? They are ozone, water vapor, etc. Okay, so 14% is absorbed directly, while 7% of energy is spread in the lower atmosphere. So the 7%, it spreads in the lower atmosphere, thus causing the earth to heat up, and the height is about 2 kilometers above the ground surface. Okay, but this amount is apparently a small amount. Okay, and the atmosphere, a a minimal part of atmosphere, it get heated up by this process. Okay, so we have another process, that is conduction. Conduction simply means, see, this is an object, it is kept near the flame. Okay, so these are flames. So this object get heated up. Now this heated object, we place it with another object which is touching its surface. Okay, so after some time we will see that this object also gets heated up. So this transfer of energy, this type of transfer of energy by touching of the object, okay, is known as conduction. So conduction can be in two ways. First is, like, consider this as an iron rod. So this part of the iron rod is getting heated up. So due to conduction, the whole rod will ultimately get heated up. Okay, so this is conduction in one body, and conduction in two body takes place similar like these boxes which we have studied. So this is how the conduction works. So similarly, in atmosphere, what happens is we have a ground surface. So this is our ground. Now what will happen? This ground in summer get heated up due to solar energy. Now when it is heated up, the atmosphere, the air which is touching the ground, it also gets heated up. Okay, and by the process of conduction, the upper air, the air above the this air layer, this layer of air, above this layer of air, we have another layer of air, and this air also get heated up by touching. Okay, as it comes in contact with the warm air, it also get warmer. And we should always remember that heat always transfer from hot body towards the cool body. Okay, so the warm surface, it transfers heat to cold surface. Okay, so this is the process of conduction, and this conduction, it is efficient, or it is effective in the lower part of atmosphere. Okay, next we have terrestrial radiation. Terrestrial radiation, it is a process of transfer of heat from one body to another without the aid of material medium. Okay, so here what happens, the heat is transferred without any medium, without the requirement of any medium like solid, any solid medium, or any liquid medium, or gaseous medium. Okay, so how the surface get heated up? There are two basic laws on it, that how by terrestrial radiation the surface get heated up. So the first law is Wein's displacement law. It states that the wavelength of the radiation is inversely proportional to the absolute temperature of the emitting body. Okay, so this is the first law of which governs the nature of flow of heat through radiation. Okay, so the first law is Wein's law. Wein's displacement law. So it says that the wavelength the wavelength of radiation is inversely proportional to wavelength is inversely proportional to the absolute temperature of emitting body. Okay, next we have Stephen's law, or it is also known as Stephen Boltzmann law. It states that the flow or the flux of radiation is proportional to the fourth power of absolute temperature of radiating body. Okay, so these are the two laws. Now, how exactly the terrestrial radiation works? So now what exactly happens is, see, we have short wave solar radiation that are coming from the sun. these get absorbed and they are emitted back in the form of long wave terrestrial radiation. And as we all know that atmosphere is transparent to short wave radiations, okay, but it is almost transparent to short wave radiation, but about 90% of the outgoing terrestrial radiations are absorbed by this atmosphere. Okay, so now what are the agents? That is water vapor, carbon dioxide, ozone. So the terrestrial radiations are the most important source of heating up of atmosphere. Okay, now this process where this terrestrial radiation is going is known as ground radiation. Okay, by this process the energy of earth, heat energy of earth, is transferred to the atmosphere. Now after that we know that counter radiation will occur. Okay, we have studied counter radiation. So now counter radiations takes place. It is similar like greenhouse and hence it is known as greenhouse effect. In it what happens is the sunlight or the solar energy which is coming, so the glasses are transparent to the sunlight which is coming, but the sunlight, it gets trapped because it is not able to move out. So the incoming is allowed but outgoing is not allowed. Okay, so same happens here and this is known as greenhouse effect. Now as we all know that the most of the density of air is in the lower atmospheric region. Okay, that is up to the height of about 5 kilometers. Okay, now we have lofty mountains whose range exceeds from 5 kilometers. So here the density of air is very low, and because here the density of air is very low, so the incoming solar radiations, I'm so sorry, so the incoming solar, this is our dense atmospheric belt which ranges up to 5 kilometers. Okay, and here the density beyond 5 kilometer is low, because of which this area is transparent, or it allows solar radiations to come and as well as terrestrial radiations to move out freely. So we have incoming solar radiations and outgoing terrestrial radiations that are moving freely in this area. So this area is also known as radiation window. Okay. Now lastly we have convection. Convection. So convection is the transfer of heat energy through the movement of mass substance from one place to another. Okay. So what exactly happens in it is, consider this as the warm object. So it is having heat energy. It moves to the cold surface. Okay. So this process is known as convection. So how it works in atmosphere, that we will see. This is a warm ground surface. Okay. Now when it gets heated up, the air present here will also get heated up by the process of conduction. Conduction. Okay. Now as it is warmer, so it becomes lighter and the air above will be cold, as compared to this one. Okay, so the cold air being heavier, it will start descending. Okay, and this warm air will start ascending. And with this, what will happen is the warm air will move upward and the cold air will come down. And because the cold air will come in contact with the ground surface, what will happen? It will also become warmer. So this is the process of convection. Okay, here the cold air which comes down, it also become warm by the ground surface. Warm ground surface. Okay, so this was the process of heating and cooling of atmosphere. Now we will study about distribution of temperature. So as we all know, if this is our earth, consider this is our earth. I'm so sorry. So when we look into basic horizontal distribution of temperature, the area ranging from 23.5 degree north to 23.5 degrees south, that is from Tropic of Cancer to Tropic of Capricorn, it receives highest amount of sunlight. That means it receives highest amount of insolation, and hence this area is the warmest area among all others. Next we have the range of 66.5 degree. So from Tropic of Cancer to 66.5 degree north, and or from Tropic of Capricorn to 66.5 degree south, this area it receives slant sunlight. Hence, as compared to this region is known as tropical region, and this region is known as temperate region. So as compared to tropical region, temperate region is much cooler, but it is much warmer as compared to this frigid zone or polar region, which ranges from 66.5 degree to 90 degree north and south. Okay, so this is frigid zone. But this is an overall view. But if we look specifically, we have various factors that controls the distribution of temperature, because here also there are various places which will have different temperature even if they are laying on the same latitude. Okay, so there are various factors which controls the distribution of temperature. Okay, so we'll study them. So the first factor is latitude. Latitude, as we all know, it is the first factor. So the latitude is our first factor. It is the most important factor as it tells us about the amount of sunlight that the area will receive. Next we have altitude. So the altitude is second important factor. Why? Because as we all know, as we move up from the ground surface, the temperature normally decreases at the rate of 6.5 degrees Celsius per 1000 meters. Okay, so this is the decrease of temperature at normal lapse rate. So here the temperature will be different as compared to this area, and this area will be much cooler. So there is a lot of difference which occurs due to altitude. Okay, why? Because here the air is much denser as compared to this area. So the air will absorb much heat, and hence it will get heated up more as compared to the area on the top. And the next reason is, this was the first reason. First reason was density of air. Second reason is, see, the area which is in contact with the ground surface will get more heated up by the process of convection, conduction, and radiation. And as we all know that the surface get heated up, the most important factor for heating up the surface is because of terrestrial radiation. Okay, so this area will get heated up more as compared to this area. And the last reason is, as the density of this area, that if it is above 5 kilometers of height, this area will be open to solar radiation as well as terrestrial radiation. Okay, incoming solar radiation as well as outgoing terrestrial radiation, it will be open to both of them. So it will not trap any energy. It will not be able to trap any energy as this one, because it will allow solar radiation to come, but here the air will not be able to move out. Sorry, here the energy will not be able to move out as the terrestrial radiation will be trapped inside. So this area will be warmer as compared to the area laying above it. Next we have distance from the coast. So distance from the coast, as we all know, we have studied land breeze and sea breeze. So the land breeze and sea breeze, they actually make the temperature or the conditions of the coastal area very calm and composed. Okay, so here the atmospheric conditions are very moderate. Okay, very suitable for living. Why? Because of land breeze and sea breeze. And as the distance from the coast increases, the effect of sea will also decrease, and because of which the area which is lying far from coastal from the sea, their temperature will be much more, will be having much more elevations. Okay, so if the temperature is cold, it will be much more cold as compared to the coastal area, and if the temperature is warm, it will be much more warmer as compared to the coastal area. Okay, next we have nature of land and water. Now in nature of land and water, we have various factors which explains the rate of heating and cooling of land and water. So if the land, as we know, it is opaque, so in it what will happen is, as the land is opaque, so the sunlight will penetrate to much less depth, and because of which the area, that is just the area of the top, about 3 feet deep, will only get heated up, and it will be very warm as compared to the water, because water actually it is transparent, so heat actually it penetrates deep inside and it is trapped. Okay, heat energy, it penetrates deep inside and it warms the water, and because the depth is more, the warming will take time. Okay, so for a specific time, if the land is heated up and the water is heated up, then the land will be, the top surface of the land will be much warmer as compared to the water. Okay, so that is the first reason, that is transparency of the object. Next we have The next reason is mobility. Now the land, it is stable and it is static. It does not move. So because it is static, it will get heated up more. Why it will get heated up more? Because it will be staying here only. It won't be able to move. So the concentration of the heat will never change. Okay, and hence the land will be more warmer and the water will be less because it is mobile. It can move from one place to another. So the water will move and hence the water will be much cooler as compared to the land. The next reason is evaporation. So the oceanic surface, here the evaporation is much more as compared to the evaporation on the land surface. So because the evaporation in oceanic surface is much more, hence the heat is spent in this process. As a result, the water, it gets less insolation as compared to land. Okay, and hence it gets less heated up, and the land, it gets heated up more. Now this was our third reason, that is evaporation. Now the fourth reason is specific heat. So specific heat is the amount of heat that is needed to rise the temperature of 1 gram of substance by 1 degree Celsius. Okay, so the specific heat of water is much more as compared to the land, and hence the energy required for warming up this water surface will be much more as compared to the energy required by the land. Okay, the fifth reason is albedo. Now in it what happens is, oceanic surface, the reflection from the oceanic surface is far more than that of the land. Okay, so because of which this area, this water, it gets less amount of energy as compared to the land, and hence it gets less heated up as compared to land. And the fifth reason was reflection or albedo. Sixth reason is, see, because the oceanic area, it is generally clouded, and because it is generally clouded, it gets less insolation from the sun, and if it is getting less insolation from the sun, then the heat energy which it will receive will be much less than that as compared to the land. So the land will get more heat energy and it will get more heated up as compared to the ocean. Hence the ocean is much cooler than the land. Okay. Next point is nature of the ground surface. So in nature of the ground surface, we see that some area is barren land, some area is covered with dense vegetation, some area is covered with snow. So if it is barren land, it will receive more amount of heat energy. If it is covered with with trees, or it is forested area, it will receive energy, but because of the shades of the tree, the distribution of temperature will be affected. Okay, so the barren land will receive highest amount. Next we have, if the area is snow covered, then because of albedo it will reflect all the energy back to the atmosphere, and hence this area will remain cool. So that was the nature of ground surface. Okay, so it is in terms of color of land or land use practices, or the land cover, how it is covered. Okay, next we have nature of ground slope. Now see, if this is a mountain and sun is shining here, so this slope will get much more heat energy as compared to this one. Okay, so the sea facing ground will be having much more energy and it will be much more warmer as compared to the other side of the mountain. Hence, the nature of ground slope also affects the distribution of temperature. Next is prevailing winds. So prevailing winds, as we all know, if we have very cold surface, we have very cold area, but here at some season or some specific time, a wind comes that is warm. So this area will become warmer as compared to the other areas in this specific latitude only. Okay, so these specific winds we have learned that local winds. Okay, so they are the major factor which one of the major factor which changes the temperature, specific temperature of the area. Okay, next is oceanic currents. So here what happens if we have very cold surface like Europe, this area is very cold surface. Okay, now because here we have warm current that is coming, so even when the whole other area are frozen, the harbor of this area are open throughout the year. Okay, and 24/7 they are open. Why? Because the warm current which is coming, sorry, the warm current which is coming, it melts the ice from this area, and hence the port are open throughout the year. So this warm current is Gulf Stream. Okay, and this area is northwestern part of Europe. Okay, and the other example is Kuroshio current, which increases or which raises the temperature of Japanese coast, and because the temperature is raised, this coast does not freeze. Okay, now as we have done the distribution of temperature horizontally and its factor, now we will learn vertical distribution of temperature. So in vertical distribution of temperature, we will study it fastly. We have thermosphere. It is closest to the ground surface of the earth. So it ranges from 6 to 16 kilometers above the earth's surface. So 6 kilometers on the poles while 16 kilometers near the equator. Okay, and here the temperature ranges between minus 50 degrees Celsius to 60 degrees Celsius, this area. Okay, and the temperature decreases at the rate of normal lapse rate. In normal conditions. Okay, now next we have tropopause. It is a static area here. Here the temperature is constant, and it is on the upper limit of troposphere. Okay, so it ranges till 18 kilometers. Next we have stratosphere. So in troposphere the temperature decreases as the height increase, while in stratosphere the temperature increases as the height increase. Okay, so because the height increase, with the increase in height the temperature increases up to 0 degrees Celsius. So from minus 50 or minus 60 to 0 degrees Celsius. Okay, and this layer also contains ozone layer at the height of 15 to 35 kilometers from the sea level. Okay, and at 50 kilometers from the ground surface we have stratopause. After stratopause we will see mesosphere, and in mesosphere with increase in height the temperature starts to decrease. Okay, and temperature, the lowest limit is up to minus 80 degrees Celsius. Okay, and mesosphere range till 80 kilometers, and at 80 kilometers we can see mesopause. Okay, and beyond mesopause we have thermosphere, and the limit of thermosphere is not known until now. Okay, and thermosphere, here also temperature starts increasing, and the range of temperature, it is as high as 1700 degrees Celsius. Okay, so that was the horizontal and vertical distribution of temperature. Now we will study most important topic, that is inversion of temperature. So what is inversion of temperature? See, normally what happens, as we move up from the ground surface, the temperature decreases. But due to some reason, there is inverse of this process. And this inverse of this process is known as inversion of temperature. So the inversion of temperature is caused by many phenomena, and these phenomena are known as, we specifically call it, or call these specific circumstances where the temperature, it increases at the as the height increases. So these specific circumstances are known as negative lapse rate. Negative lapse rate. Okay, so here the temperature increases with the increase in height. So the inversion of temperature can be of various type. So we will study the basic type of inversion of temperature. So the first type is non-advectional inversion. In non-advectional inversion, we have two basic types, that is ground surface inversion or upper air inversion. So in ground surface inversion, what will happen? It is also known as radiation inversion. Here, simply what happens, this inversion is caused during long cold night, okay, in snow covered region. So we have snow covered region in mid or high latitude area. So we have long cold night. Because of it, what happens is, there is excessive cooling of ground due to rapid loss of heat from the ground surface. And how this ground surface loses its heat? By terrestrial radiations. So now what will happen is, this is the ground surface, and here we have air. So as the ground surface is losing lot of heat and it is cooling down rapidly, so the air which comes in contact with the ground surface, it also becomes cold. Now the air that is lying in this layer, it is cold as compared to the air lying above this area. Okay, so this air is warmer as compared to the layer lying below. Okay, so this causes inversion of temperature, as the air below is having less temperature than the air above. Okay, and because the ground surface inversion, it requires certain specific conditions. First is long winter night, so that the loss of heat energy by the terrestrial radiations from the ground surface may occur during night. Okay, second is cloudless or clear sky, so that the loss of heat energy through the terrestrial radiation proceed more rapidly. Third is presence of dry air near the ground. Why? Because if the air is moist, it will not become as cold as the dry air. Okay. Second, we have next reason, we have slow motion of air so that there is no transfer or mixing of heat. Lastly, we should have snow covered ground so that there is maximum reflection of incoming solar radiations. Okay, so that the ground is very cold. And this type of inversion is caused by static atmospheric condition, that is there is very little movement of air, hence this is known as static or non-advectional inversion. Okay, next we have upper air inversion. Upper air inversion is basically of two types. First is thermal upper air inversion, next is mechanical upper air inversion. Okay, so this thermal upper air inversion, it basically happens in the stratospheric layer which contains ozone layer. So here we have ozone layer, and this ozone layer, as we know that ozone being a greenhouse gas, it absorbs heat energy. Okay, so this ozone layer, it absorbs heat energy, and because it absorbs heat energy, it will become warmer. So it will be warmer than the air laying below this ozone layer. Okay, and this layer will be, this is warmer and this layer will be cold. Okay, so here also what will happen, the inversion of temperature will occur as the low laying air is colder and the upper air is warmer. Okay, now in mechanical upper air inversion, what will happen, this is the air, this is the mountain surface, so here we have cold air. So because of AD's formation, this air, that is the air above, will be replaced by the warm air. Okay, if the warm air it comes, and this air will be replaced by the warm air, so we have warm air laying above the cold air, and hence we can experience inversion of temperature. So this was the one reason why the mechanical air inversion occurs, where the air is displaced or transported, warm air is transported upwards. Okay, and because the warm air is transported upward, we will have warm air here and the low lying air will be colder. Okay, now the next reason is the descending air, it sometimes decreases or it sometimes warm itself at the rate of dry adiabatic lapse rate. Okay, that is 10 degrees Celsius per 1000 meters. So if its temperature is 30 degrees Celsius here, as it will come down, its temperature will become 40 degrees Celsius. Okay, so because of compression, this dry adiabatic lapse rate will occur. So here what will happen, this air will be much warmer than the air laying below. Okay, because they are increasing, their temperature is increasing with the normal lapse rate. Okay, while this air, its temperature was increasing with dry adiabatic lapse rate as it was descending down. So it will be much warmer as compared to the air laying below. Okay, so this will also cause atmospheric inversion of temperature. Next we have advectional inversion. In advectional inversion we have first, that is frontal inversion. Advectional inversion are also known as dynamic inversion because they are always caused due to horizontal or vertical movement of air. Okay, so the frontal inversion, they are also known as cyclonic inversion, and they are caused, as we all know, that fronts are formed basically in temperate region. Okay, why? Because warm air, it converges with cold air. So if this is the equatorial region, the warm air will move from here and the cold air will move from here. So this warm air will be having contrasting characteristics as compared to the cold air. So when they will come, they will form front. So we have basically these front formation in the temperate region. Okay, so here the warm air is pushed upward and the cold air, it descends down, and thus what will happen? The reverse of normal lapse rate will occur. That is, the temperature will increase as we move upward, and hence the inversion of temperature will take place. Next we have valley inversion. Valley inversion, here what will happen is, so during winter times, this is the valley. Here the temperature, it becomes, here the temperature of the ground surface, it becomes excessively less, and because of which the air coming in contact with this ground surface, they also become cold. So we have cold air that is present here, that is present below, and the warmer air is present above. So hence we can experience valley inversion and inversion of temperature. Lastly, in advectional inversion we have surface inversion. So the surface inversion or the surface inversion of temperature is caused by horizontal movement of air. Okay, so in this inversion what will happen? The warm air will invade the area of cold air, and the cold air will move into the area of warm air because the warm air, being lighter, is pushed upwards by the relatively denser cold air. So what will happen? This is the cold air, it being denser, it will move downward and the warm air will be pushed upward. Okay, and hence what will happen? Inversion will occur as the warmer air is moving upwards. So the temperature of upper atmosphere or upper layer will be more than the layer laying below. Okay, lastly we have mechanical inversion. So one type of mechanical inversion we have already done. We have subsidence inversion. In subsidence inversion what will happen? The air being cold, it will subside. Okay, and hence what will happen? The As it will subside here, so this will be cold and the air laying above this one will be warmer, and hence the inversion of temperature will occur. So that was all in inversion of temperature. in subsidence inversion. Now in convective inversion, as we have done in convection, the warm air being lighter, it will ascend upwards, and hence the air which is colder, it will come down, and hence what will happen? The cold air will be laying below the warm air, which will make negative lapse rate or which will inverse the normal lapse rate, and hence the inversion of temperature will be caused. So the temperature inversion will be caused here. So this was all about inversion of temperature. So that was all for today, guys. I hope you enjoyed the lecture today. So let's meet in our next class. Till then, take care and have a nice day.